So in our endless quest to be able to acquire the skills to solve any type of equation, what we should have discovered along the way that there have been up to now two basic steps for us to consider. Now, I don't want you to think of that as meaning that every equation we've solved has been a two-step equation. It just means that there have been two basic steps for us to consider in getting to the final solution of an equation. The first step that we would consider is in isolating the variable term or confirming that the variable term is already isolated. And that just means that the variable term is alone, all by itself to one side of the equation. And then the second step for us to consider is once the variable term is isolated to one side of the equation, is actually following through on solving the equation. And that's usually where we get into using our inverse operations. Those operations typically being using multiplication to undo division that may be occurring between the variable and a value, or using division to undo multiplication that's occurring between a value and the variable. So up until this point, even though both steps may not come into play, then we're at least checking to see which steps need to be put into play for solving an equation. Beyond that, I want to make sure that we do actually understand the terminology of what the pieces of an equation are. A variable term is exactly as it sounds. It's a term that includes a variable. So something like 3m. So as an example, something like 3m is a variable term. Or we'll say something like x over 5 is a variable term. And a constant term is going to be a term without a variable. So examples of that might be, so if I look at an equation like 5x minus 9, we will say equals 2, then our constant terms are the numbers that don't have the variable. So it's important that we understand when we talk about this whole idea of isolating, the variable term, that we're actually looking to separate this term with the variable from the other two terms that are constants, okay? So up until this point, we've been fortunate that even if we've wound up having to solve a two-step equation, that generally speaking, it's had one of those two types of terms isolated already, or partially isolated, I should say. So in this example, the 2 as a constant term is already isolated, so it would make sense to bring that minus 9 over using reverse order of operations to isolate the variable term. But what we discovered in today's discussion about the one equation that I think we spent a decent amount of time on is now we have to accept the reality that there are going to be equations that have a variable term on both sides and a constant term on both sides. Okay? And as a result, there's going to be some extra steps involved in getting the variable term isolated fully. So in the one equation we talked through in class today, we discovered there were really 4 points of entry, as you recall me talking about. We could have, in using this equation, one option is for us to move the 7n from the left to the right by subtracting it from both sides. So I could show you that. I could subtract 7n and subtract 7n. Now, you don't have to write this down at the moment. I'm just trying to show you visually what our choices are. So one option is subtract 7n on both sides to begin to isolate the variable term. Another option would be to undo the plus 4. So we'd be subtracting 4 on both sides. And notice when I do that, then if it's a variable term that I'm adding or subtracting, I'm making sure to stack it under the other variable term. Or if it's a constant term, as is the case here, that I'm adding or subtracting, then I'm stacking it underneath its partner constant term when I add or subtract to both sides. So those are two of the steps that we could consider. The third step we could consider in beginning to isolate is to subtract the 10n on both sides. That would make the 10n cancel here and get it to go join over on the left side of the equation. And then finally, the last alternative would be to undo the minus 11, so we'd have to add 11 on both sides. Now, any of those 4 steps is a first step that we can consider. But for our purposes, what I'm always going to focus on, this is not a requirement, but there's some helpful results of it. What I'm going to focus on is moving one of my variable terms first, and I'm going to move the lower of the 2 variable terms. So what I'm always going to try to do is to move lower variable term as, step 1. So one variable term has a value of 7n. The other variable term has a value of 10n. Which one is lower? Well, 7n is lower. So that's the one I'm going to move. So I'm going to move it by subtracting 7n on both sides. By subtracting 7n on both sides. So the 7n will cancel, and I'm going to get 4 equals, and 10n minus 7n is going to give me 3n plus 11. I'm sorry, minus 11. So we're beginning to see this is taking shape like a very traditional 2-step equation where I have a constant term already isolated on one side, on the left side of the equation, and a variable term and constant term together on the other side. So this should get us quickly within our comfort zone. And by making this our first step of the 4 that we had to choose, by moving this lower variable term first, the lower variable term first, then it allows me to get into a traditional looking 2-step equation. So from here, even though our equation is backwards, we should be able to see the next step is to undo the subtracting 11. So we're going to add 11 on both sides. In doing so, the 11s cancel, and 4 plus 11 is 15, and that's going to equal 3n. Now again, my equation is backwards, but it doesn't matter. At this point, it's a 1-step equation. So the very final step I have to be concerned with, we should see easily, is divide both sides by 3. So the 3's cancel, and I'm going to get n equals, and this is where I'm going to remember to flip my solution around, n equals 5. So that required technically 2 steps in isolating the variable term. The first step was here where I subtracted 7n. The second step in fully isolating the variable term from the constant term was adding 11 on both sides. And then I could move on with any remaining steps in the equation, in this case dividing by 3. So that's how we're going to approach any of these equations in which there is a variable term on both sides and a constant term on both sides. So I'm going to walk you through one more equation in a similar way. So I'm going to follow this rule of moving the lower variable term as step 1, and then we'll just let the equation play out from there, or let solving the equation play out from there. So there's a variable term, negative 5a. There's a variable term. If we need to understand what a means, it really means 1a. So if you need to write the 1 in front of it as a coefficient, you can feel free to do so. But on each side, there's also a constant. Okay, so sticking with the idea of moving my lowest valued variable term first, I have the choice of either moving minus 5a by adding it to both sides, or moving 1a by subtracting it from both sides. Now, which of these has a smaller value? And that's really just a matter of envisioning on a number line which coefficient is a smaller number. Is negative 5 smaller than 1, or is 1 smaller than negative 5? Well, we should all know that negative 5 is a smaller number on the number line. So that's the term I'm going to move. So to undo subtracting 5a on the left, I'll have to add it. But being that it's an equation, I'll have to add it to both sides. And notice that I'm stacking my variable terms underneath each other because they're essentially the equivalent of like terms. So that's going to leave me with 2 equals, and a, or 1a plus 5a, is 6a plus 32. And again, this equation happens to look backwards to me, but it should look very much like a very typical 2-step equation. Variable term plus constant term equals constant term. So I should be within my comfort zone at this point to realize that the next logical step is to fully isolate the variable term by subtracting 32 on both sides, That will make the 32's cancel out. Now, if you're going to get confused by the 2 minus 32, think about keep change opposite, 2 plus negative 32. Set up your scoreboard as you need to, and finish solving. So we know we should get negative, and the difference of those numbers, negative 30, is equal to 6a. So it took us 2 steps to get fully isolated. My variable term, 6a, is fully isolated from my constant term. It took us 2 steps. In this case, it took us the first step of adding 5a, and the next logical step is the second step, subtracting 32 on both sides. So my final step is going to be to finish solving this one-step equation that we've created. And that's going to be done with the idea of inverse operations. So we'll undo the multiplying of the 6 and the a by dividing by 6 on both sides. That will cause my 6's to cancel. I am going to get a solution that's backwards, so I'll just be careful not to say, in this case, negative 5 equals a. I will rewrite it in the correct order, a equals negative 5. And that is how we solve equations with more than 2 steps in which there's a variable and constant on both sides. So from there, I'll ask you to practice the remaining 3 on your own.